Just running through a proof of Euler's rule. Now, if you let z, let's just let f of theta equal that. Let f of theta equal cos theta plus I sine theta. Then if you look at f dash of theta, you get minus sine theta plus I cos theta. Now, when you look at that then, if you take out an I out of there, factorise an I out, you will get minus. Now, if you take an I out of there, that would be I sine theta and plus cos theta. Now I'm just checking the sign there. If I took an I out, this is going to be plus for it to go back to minus sine theta. So that means that's going to be I cos theta plus I sine theta, which equals I f of x, or f of theta, sorry. Okay, so that means that I is equal to f dash of theta on f of theta. Now, if we just integrate this with respect to theta on both sides, that will be ln of f of theta equals I theta. And then we go plus c. Now, initially, because f of theta equals cos theta plus I sine theta. Okay, if we let f theta equals 0, then that would be cos 0 plus I sine 0, which equals 1. So f of 0 is 1. So that means that ln of f of 0 would be I times 0 plus c. Now, f of 0 is 1, so that's going to be I times 0 plus c. And ln 1 is just 0. That means c is 0. So that means f of theta equals cos theta plus I sine... Let's go back up to what we just got there, which was this one, when we integrated. The c is 0. So that means that ln of f of theta equals I theta. So that's log base e of f of theta equals I theta. So that means if we go e to the I theta equals f of theta. But what is f of theta? F of theta is cos theta plus I sine theta, and that equals e to the I theta, which is your required result. Now, being able to put something in index form, working with indices sometimes makes things a whole lot easier and helps us to establish a lot of our rules to do with trigonometry. So that now gives us the tool. If we've got e of pi on 6, that's the same as cos pi on 6 plus I sine pi on 6. So it's cos 30 plus I sine 30. Cos 30 is equal to root 3 on 2, and sine 30 is just equal to 1/2. So that's going from Euler's rule to putting it into mod arg form. Basically 2, if you have e to the I theta, that will be equal to r cis theta. And that just makes putting things into mod arg form quite easy. So if you wanted to put minus 1 plus, say, root 3i into the form of r e I theta, then the r is the modulus of this, which would be 1 squared plus root 3 squared, which is root 4 or 2, and tan theta equals root 3 on 1. Tan theta would be minus 1 plus, it'll be in that quadrant there. So it's pi minus pi on 3, because when tan equals root 3, it's 60. So that means theta is 2 pi on 3. So that means that we can have it as 2e to the I 2 pi on 3. Just noting with all of these, the modulus is the magnitude and the angle is like your direction of your vector. This then makes it really easy to then, like say you've got z equals root 3 plus I, and you want to evaluate root z. Because that means if you've got root 3 plus I, you can put it in the form of 2e to the I pi on 6, and then it's root 2e to the I pi on 6 to the power of a half. So it's root 2e to the I pi on 6 times 1/2, which is the same as root 2e to the pi on 12. And that slips it into mod arg form, really easy, because all we've done there is we've just used, that's got an I in there. We've just used Euler's rule and all the rules of indices just to make it a little bit easier to do stuff. Alternatively, I mean, you could also use, like, you go root and you just got in 2 cis pi on 6, which is 2 cis pi on 6 to the half, which is root 2 cis pi on 6 times a half. Because using de Moivre's theorem, you can just break it in. So it's root 2 cis pi on 12. Okay, so let's just have a look at this question. So cos squared pi on 4 equals 2 cos squared... Oh, sorry, not cos squared pi on 4. Cos pi on 4 equals 2 cos squared pi on 8 minus 1. Then what will this equal? Okay, so if we start off and we just go, all right, 2 cos squared pi on 8 minus 1 equals cos pi on 4. That means cos squared pi on 8 equals 1 plus cos pi on 4 on 2. So cos squared pi on 8 equals 1 plus 1 on root 2 on 2, which is root 2 plus 1 on 2 root 2. Now, if I realise that, I multiply top and bottom by root 2, so I get 2 plus root 2 over 2 2's are 4, and that what's cos squared pi on 8 equals. So that means that cos pi on 8 would be the square root of 2 plus root 2 on 2. Now we could do the same thing with sine squared pi on 8. Sine squared pi on 8, that will equal, I know that equals a half, 1 minus cos pi on 4. So that's going to be 2 sine squared pi on 8 equals 1 minus cos pi on 4. So that means that sine squared pi on 8 equals 1 minus 1 on root 2 on 2, which is root 2 minus 1 on 2 root 2. If you realise that, you will get 2 minus root 2 over 4. And then to get sine pi on 8, you square root it, 2 minus root 2 on 2. So now what we actually have here is what sine pi on 8 equals and what cos pi on 8 equals. So then we have cos pi on 8 plus I sine pi on 8. And that's going to be equal to the square root of 2 plus root 2 on 2 plus I, the square root of 2 minus root 2 on 2. So that's a half times like all that. So that's actually going to be equal to, that is exactly the same as cos pi on 8. So it's going to be e to the I pi on 8. So when you are looking at this multiple choice question here, it's e to the I pi on 8 will be what will be equal to this number.